Take the number I, just I, sitting 1 unit up the imaginary axis. Now multiply it by itself. I times I is -1. Everyone learns that. But look at where it lands. 1 sits at the right, on the real axis I sit straight up, and -1 sits to the left. So watch what multiplying by I actually did. It took 1, pointing right, and turned it into I, pointing up. A quarter turn. Then it took I and turned it into -1, pointing left. Another quarter turn. Multiply by I again and you get -I, pointing down. And once more brings you home to 1. 4 steps, 4 right angles, a full circle. So multiplying by I isn't really about the number -1 at all. It's a rotation, 90 degrees every time. And that's the little crack we're going to pry open. Because if I rotates by 90 degrees, maybe every complex number rotates by something. Let's set it up properly. Any complex number, call it Z, lives somewhere on the plane. It has a real part and an imaginary part, sure. But it also has 2 other things that matter more here. It has a length, how far it is from the origin. We call that r, and it has a direction, the angle it makes with the positive real axis. We'll call that theta. So instead of writing z as a plus bi, let's write it using its length and its angle. The point sits at r cosine theta across and r sine theta up. So z equals r times, in parentheses, cosine theta plus I sine theta. Same number, we've just described it by how far and which way instead of across and up. Now here's the question that cracks it open. What happens when we multiply 2 of these together? Let's keep it clean and use 2 numbers that both sit on the unit circle so their lengths are just 1. The first one has angle alpha, so it's cosine alpha plus I sine alpha. The second has angle beta, cosine beta plus I sine beta. 2 points on the circle, 2 directions, let's multiply them and just see what falls out. We expand it the way we always do, every term times every term. Cosine alpha times cosine beta, then cosine alpha times I sine beta, then I sine alpha times cosine beta, and finally I sine alpha times I sine beta. That last one's special because it has I times I in it, and I times I is -1. So that term flips its sign. It becomes negative sine alpha sine beta. Now let's sort the pieces. Gather the ones without an I, the real part. We've got cosine alpha, cosine beta minus sine alpha sine beta. And gather the ones with an I, the imaginary part. That's sine alpha cosine beta plus cosine alpha sine beta. And maybe those look familiar. Because they should. Cosine alpha cosine beta minus sine alpha sine beta. That is exactly cosine of alpha plus beta. The angle addition formula, the one you maybe memorized once and forgot why you'd ever need. And the other piece, sine alpha cosine beta plus cosine alpha sine beta. That's sine of alpha plus beta. So the whole product collapses. It's cosine of alpha plus beta plus I sine of alpha plus beta. Look at what that is. It's another point on the unit circle. And its angle? Alpha plus beta. We took a direction of alpha, multiplied it by a direction of beta, and got a direction of alpha plus beta. The angles added. That's it. That's the whole secret. When you multiply complex numbers, their angles add. And once you've got the unit circle case, the general one is easy. Put the lengths back in. If the first number has length r and the second has length s, those just come along for the ride, out front. R times s, the lengths multiply and the angles add. So the product has length rs and angle alpha plus beta, which means multiplying by a complex number does 2 simple things at once. It scales, it stretches or shrinks by the length, and it rotates by the angle. That's all multiplication ever was, hiding in plain sight. Now go back to I. What's its length? 1. So it doesn't stretch anything. What's its angle? It's pointing straight up, 90 degrees. So, multiplying by I adds 90 degrees to whatever you've got and changes the size not at all. A pure rotation, a quarter turn. Exactly what we saw at the start, but now we know why. And it didn't come from some special property of I. It came from one line, I times I is -1. feeding through the distributive law, with the angle addition formulas doing the rest. The rotation was baked in the moment we decided I squared should be -1. So next time you multiply two complex numbers, picture it. Two arrows. Their lengths multiply, their angles add. One turns the other. What other shapes can you make this way? Square a number, you double its angle. Cube it, you triple it. The roots of one spread out evenly around the circle like spokes on a wheel. What else is hiding in that picture?